Let's take a look at this example. This time we're supposed to find maximum and minimum value of the resistance RL. Please notice that we have given maximum power and minimum power of the Zener diode. We have also given voltage source and resistor RS. I'm going to start solving this problem from finding voltage across resistor RS. Someone is going to ask why I'm supposed to start to solve this problem from voltage VRS, because this voltage is going to help me to find the total current in the circuit, current IS, and IS is basically the key to solve the whole problem. So I'm going to use KVL in order to find this voltage, which says voltage RS is equal voltage source minus Zener voltage, which is equal voltage source is equal 20 volts minus Zener voltage, which is equal 10 volts, equals 10 volts. I have a voltage across this resistor. Next, I can find the current IS. IS is equal VRS over RS, which is equal VRS 10 volts over 200 ohms. This is equal 50 milliamps. I found the total current IS. Next, I'm going to find minimum and maximum current which will go through this diode. Formula for power says power is equal current times voltage. In order to find current, I have to divide both sides equation by V. V and V will cancel out, and I'm going to have current equals power over voltage. I'm looking right now for IZ minimum, which is going to be simply calculated by dividing PZ minimum over VZ. This is equal, PZ minimum is equal 150 milliwatts over VZ, which is equal 10 volts. This is equal 15 milliamps. This is the minimum current which will go through this diode. Next, I can find IZ max, which is going to be calculated by dividing PZ max over VZ, which is equal 400 milliwatts over 10 volts, which is equal 40 milliamps. This is the maximum current which will go by my Zener diode. Next, I'm supposed to find the minimum and maximum current which will go through this resistor. Someone is going to say why? Because formula for resistance says resistance is equal voltage over current, Ohm's law. So that's why I have to find the currents which will go through this resistor. IL minimum is going to be found by finding the difference between I source and IZ max minus IZ max. Remember, in order to find the minimum current which goes through resistor RL, you're supposed to subtract from IS IZ max, and you will find IL minimum. This is equal I source equals 50 milliamps minus IZ max, which is equal 40 milliamps. So IL minimum is equal 10 milliamps. This is the minimum current which will go through this resistor. Next, I'm supposed to find RLmax. In order to find RLmax, you're supposed to subtract from IS, IZ minimum. One more time. In order to get maximum current which goes through this resistor, you're supposed to subtract from source current the minimum current which goes through the Zener diode. RLmax is equal I source 50 milliamps minus IZ minimum, and IZ minimum is equal 15 milliamps. 50 milliamps minus 15 milliamps is equal 35 milliamps. Now, we have voltage across resistor RL. Please notice that this is the parallel circuit. That's why VZ is equal to RL. And this is equal 10 volts. And we have currents needed to find the resistance. That's why we can calculate resistance. RL minimum is voltage across the resistor, which is VZ or VRL. It's the same thing. Remember, these two components are in parallel. That's why I can call them VZ or VRL over RLmax. Anytime you want to find the minimum resistance, you have to divide the voltage across the resistor by the maximum current which will go through this resistor. This is equal 10 volts over RLmax, and RLmax we found is equal 35 milliamps. This is equal 285.71 ohms. This is the minimum value of this resistor, and RLmax is equal VZ over IL minimum. So I have 10 volts over IL minimum we found is equal 10 milliamps, and this is 1 kilo. And these are the minimum and maximum values of the resistor RL in this circuit. These are the solutions to my problem.